All right, the following table presents the average points scored per game for the 30 NBA teams in the 2012-2013 regular season. Make a dot plot to display the distribution of points per game. Then use your dot plot to make a histogram of the distribution. So we're going to start with the dot plot. Now, when you do a dot plot, we have one piece of data. We're looking at points per game, average points per game. And we need to look at, okay, what's the highest points per game we see and the lowest, because that will help us indicate where our scale needs to start and stop with the dot plot. So if I look at my table carefully, I notice that the smallest points per game was the 93.2 with the Chicago Bulls. And the largest points per game in this year was the Denver Nuggets at 106.1. So when I do my dot plot, I need to make sure that the x-axis uses those values. It doesn't have to start at 0. Just start somewhere and evenly scale to include 106.1. So I'm going to draw my x-axis and I scale it, label it, put the units at the bottom, and then I put one dot on my dot plot for each of the teams. And you can see how this all took place. It's a little time consuming, but you can see generally what's going on. But it is a little difficult to see shape because they're all kind of spread out and there's not huge amounts of discrepancy, if you will. So that's the dot plot. So it's hard to analyze shape when the points are all spread out. So this is why we would want to prefer a histogram, quantitative data with a histogram. So in the next following slides, I'm going to show you how do we create a histogram using the same set of data. All right, so here's your steps on how to create the histogram. So first you're going to group the data into groups, or sometimes I call them bins, of equal length. And you'll want at least 5 groups. All right? So by that, I'm looking at the points per game, looking at the smallest and the largest, and you want to evenly distribute them. So here's how I would group them. 92, 93, 94, 95, 96, 97, 98, 99. So the groups have a width of 2, 92, 93. Each has a width of 2 units. And I have enough groups to incorporate the smallest and the largest piece of data. You don't have to have this many, but you want at least 5 to really be able to see shape clearly. Then what I'm going to do is go line by line through the data and put a tally mark into which group the piece of data falls. So once I've gone through the table, I've done my tally marks, and I can see, like in this group, there's 5 pieces of data. In this second group, there's 6. This one, there's 5. This one, there's 3. Then 6. Then 3, 2, 1, and 2. All right, great, awesome. So then, when I create my histogram, I label my y-axis as frequency, and the frequency is this second column in my table over here. So notice that my frequency really doesn't have to go any higher than 6 on my scale. So always look at your frequencies before you just scale 1 to 100 or whatever. This one only needs to go to 6. So you want to scale it well enough so that you can see the differences in height and not be extreme about it. Now the x-axis are your boundary values, and you don't want to forget to label the units on it. So my boundary values will, like, one boundary will be 92, one will be 94, 96, 98, on and on until we get to 106. So what does this look like? Well, here it is. Notice that my y-axis really went up to 6. That's all I needed, but I labeled it frequency because that means I've counted. My x-axis is points per game. And I've labeled my boundary values. Notice I don't put 92, 93. I just put the left-hand boundary on there because that indicates that 93 is in this first bin and 95 is in the second bin, and so on and so forth. So then I draw my bins and shade accordingly. Notice that the histogram, the bars are touching. You want them to touch unless there's a gap in the data. You definitely want them to touch. So that's how you create it. Now, realistically, creating a histogram is very time consuming. So you're not really going to have to do this on the AP exam, and I wouldn't have you do it on one of our exams because it is so time consuming. However, knowing how to create one helps you know how to interpret one. So it's important that you understand the process. Now the second part of the question said to describe the distribution. So I've just copied the histogram here so we can use it to reference as we write our few sentences using the SOX acronym. All right? So here's the model answer for you. The distribution of points per game, there's my context, for these 30 NBA teams is skewed to the right with a center around 97 to 99 points per game. Okay, so the center is kind of the balance point, remember? Somewhere in here. Don't know for sure, but we're ballparking it. The spread is from 93.2 to 106.1, so I've labeled the minimum and the maximum. I said spread, do not say range, say spread if you do this, per game with no apparent outliers. So then I think through, do I have all the components? Do I have shape? Well, there it is, skewed to the right. Do I have their center? That's the C. Spread is right there, and then outliers. Notice they don't have to go in the order of socks, but they can, it doesn't matter. And notice you don't have to have 4 separate sentences. Really all I have right here is 2 sentences. I just incorporated them all. I also have context, and I have, I don't need comparison words because I'm just doing one distribution. I'm not comparing it to another. But I do need context absolutely every time. All right, so before we move too much further, let's just stop and pause and think about what are the differences between a bar chart and a histogram. They both have bars, agreed. But what's the difference? Well, with a bar chart, it is categorical data that is on the horizontal axis. Okay, remember we had those categories of age groups when we did the cell phones previously? That was a bar chart. But on a histogram, it's ranges of quantitative data, like we did ranges of points per game, 92, 93, 94, 95. So on and so forth. They were quantitative data. So histograms quantitative, bar charts are categorical. On a bar chart, we do create bars, yes. On histograms, I call them bins, right? Those bars are called bins. On a bar chart, spaces between the bars are required. They are not to touch on a bar chart in most cases. Sometimes they do, but in most cases they don't, just for easy reading. But on a histogram, there are no spaces between the bars unless there happens to be a gap in the data, like there's no data in that range of values. So you want them to touch unless there is a gap in the data. So make sure you can differentiate those things. Now I wanted to show you in your calculator, you can create your histogram if you were asked to create one. And it's rather fast, but and I will show you the keystrokes. You have them in your notes, but I just want to model it for you. So the first thing you'd have to do is enter those points per game in this example into list 1, which I've done. And then I'm going to go to my stat plot menu, turn the first plot on, and right here, the third option over is the histogram. That's the one we want. So I make sure to highlight that. The X list, the list of my data is in L1. Leave the frequency alone. Doesn't really matter about color. You may not even have that option. Once this is set, I would then hit zoom 9 to get the stat menu looking. And there's my histogram. Now, in the calculator, they don't have room to label the axes, but you would still have to do that for sure. So how do you read this? Well, if you hit trace, it will tell you everything you need to know about this bin. It tells you that the minimum value was 93.2. The maximum value is 95.35. So the calculator does it bins by decimal values. We obviously don't, but the calculator is more precise. But it does tell you n equals 11. That tells you there's 11 pieces of data in that one bin. And then if I arrow over, it'll move to the next bin. And so let me pay the minimum value here is that the maximum is less than, because the next bin starts at 97.5. There's 5 in that bin. And I trace over, there's 4 in the next, 5 in the next, 4, 2, and 1. Now, this is not exactly the way we did it on the notes, but we did it by hand. So we did it by whole number of values. The calculator did it slightly different, but we really end up with the same results. You should end up with the same shape, same general center, and spread, and all of that. It should come out the same. But again, creating a histogram is time consuming. You can use the calculator really quickly if you need to see what is the shape of the distribution. The notes are in the next slide. They are also in, the keystrokes are in the next slide as well as in your notes. So here's the keystrokes I just modeled for you. You are welcome to play along with that or play with a set of data and get used to finding histograms on your calculator.